Hello and welcome. This will be our final presentation for the term project of MMI513. My name is Ali Ozan.
And I am Nuri Baran Ayana.
Let's quickly start with the introduction of the project. First of all, the base project selection was the first step we took. We have searched, investigated, and looked for lots of different projects and compared them in terms of their recency, their dates, their originality, complexity, and the similarity of the original game, uh, and of course the ease of modification because we at the end have altered the projects. uh, I have checked the similarity to the original game because there are lots of Pac-Man projects, but some of them are like a whole different implementation of it. So we have found some really good and detailed projects actually, and we have experimented with them, tried them, and at the end we have decided to stick with a project that has a more simplistic approach to its visuals, and I will explain the reason. For example, as you can see, the first image on the left was a project we actually have worked on. It was quite a good project. It was a really decent implementation of the original game. It looked better. It had animation, sounds, everything was present, but the walls was curved, and the rendering process was according to it, and it had some rotational matrices for sprites and some positional matrices for these sprites, and it was very challenging for us to dynamically create a maze and make the curves like this, like the edges like curved, and this was
And also, I would
yeah.
like to add something. The games were really hard to implement the algorithms. As
Yeah,
you can see from the left part, the generation of the maze pathfinding algorithms, AI behavior. So, in this kind of projects, really makes challenging implementing the algorithms.
yeah, of course. And at the end, the image on the right is the project that we have selected and worked on at the end. It looks uh, exactly like the original game, but it has blocky walls, so we can easily create new mazes without a problem. Uh, the base project, let's explain it with a bit more detail. It is a simple but accurate implementation of the original game. Map is exactly the same. The map is actually defined with a by the ASCII characters. So it has zeros for the walls, ones for the open path, P stands for player, O stands for power-ups, and G stands for ghosts. And power-ups, teleport gates on at the middle, they work fine. And ghosts have two movement modes. That is important. One is chase, and the other one is scatter. Chase is their mode when it's the default mode of the ghosts. They try to chase the player, and the scatter mode is the mode that gets activated when the player uh, collects a power up. But these movements at the base project are not ideal. They have a major issue. They do not update their targets until they reach it. For example, they see a player at a place, they want to reach it, they create a path, but player moves away, they still try to go to the snapshot they see at the beginning. So they practically chase a history of the player. So it is
Yeah.
not accurate. It is not very good. So we have uh, done quite a lot about it, and Baran will talk about it in detail. So without getting into more detail, I want to show a quick demo of our project. So let's run our project with its current state and see what changed. So as you can see, this is the current state of the project, it creates a maze using a Prim's algorithm, and everything works fine. You can eat the ghosts, the portals works okay, and power-ups works all right, and ghosts are
Chases the
ghosts.
player, as you can see.
They chase the player when they sense the player. So all the basic implementation is there. Uh, so let's talk about the
Also,
details.
I would like to add something.
Yeah,
Differently from the games, we have dynamically generates the maze. So each time you run the game, we are going to see the different mazes,
yeah,
and we have the sensing mechanism. The ghost always chases the player in the according to the Manhattan distance or the another hyperparameters. So we have turned in the game we have provided also a diversity and a more intelligent game, conversely with the base project.
yeah. So let's talk about the details of the current state of the project and what we have done and what we have achieved so far. So the maze generation, we have used the same approach by defining a 2D maze with ASCII characters. First, we have tried the depth-first search algorithm to create a maze, and then later we have also implemented the Prim's algorithm as our default method. And by this, we had the chance to actually compare these algorithms in a game environment. And Pac-Man is a very suitable game, a very suitable environment to compare these maze generation algorithms. And why did we choose Prim's algorithm as our default choice at the end? Because depth first search usually resulted in long and winding corridors and some dead ends in the maze. And for a game like Pac-Man, where the player needs to run away, these resulted in a very hard game to play because when the ends of the corridors are closed by the ghosts, the game is done. So having some escape routes is crucial. Uh, but Prim's Maze, on the other hand, provides a more flexible and more open maze with a more forgiving game design at the end. So we can visually compare them in this slide. As you can see in the first picture, you can see the depth first search maze created with our method. It has some long and winding corridors. It looks all right. It is okay, but uh, and the second image shows the Prim's maze. It usually creates a more entertaining.
Open maze, and
Yeah,
the previous maze on the left is just one directional.
yeah,
On the right, the Prim's maze algorithm, it is the multi-directional, so the player can escape to the different locations, can go to different directions. But that first search designed maze really makes the game more boring than the Prim's maze, I
yeah.
think.
It is a little harder. So this was a nice comparison that we have done in this method. So the workflow of the maze generation is we create a 2D grid only consisting of walls, only zeros. We carve out the corridors using the depth first search or the Prim's algorithm. That depends on how we run the scripts. And we pick a random place for the player. We pick uh, random places for the power ups, and we also open some portal gates. And this is also random. It chooses randomly among the rows that has the first and the last grid as open spaces. And it chooses among these rows randomly with a predetermined count. For example, we have 5 portals by default. And that is all for the maze generation. Baran will continue with the strategy AI.
Thank you very much, Ozan. So I'm going to continue after now till the end. The basic objective of the strategy AI is the placement of for spawn locations for the ghosts. So we have mentioned about the diverse locations and the generic mazes. So each time we run the game, we see different mazes, different maze, and different Pac-Man locations. So the strategic AI part is you has used the breadth first search algorithm. So according to the diverse set of the mazes and the players, it's the strategic AI block uh, locates the ghost from the 10 unit distance from the player. So this provides the player to go in a flexible way to the different directions. So we don't want our player to die at the end and stop the game. So this is really the crucial as a strategically to win the game. And another the ability to that I want to mention is the new ghost generation. And while the player cannot end the game, cannot win the game, a new ghost is born. And we have set the parameter, the time is at 60 seconds. So at each 60 seconds, the new ghost is born with the different color. So this makes the game challenging if the player cannot win and cannot end the game. So new ghost is born and the game becomes more challenging.
Yeah.
So another the behavior we have gained and to the game is a tactical part. The main difference of the tactical part from the strategy part is a tactical part is the behavior during the playing of the game, but in the strategy part is the behavior before starting the game. So the main objective is the game for the making the ghost to have sensing mechanism. This sensing mechanism is evaluated with Manhattan distance. The Manhattan distance is a metric that calculates the distance by considering the routes. For instance, if the ghost might be really close to the player, but if the wall is between them stays, and according to the route, the distance is the 15 units, the ghost cannot sense the player. So this is the realistic metric and the realistic distance in terms of the Pac-Man game. So if the score is bigger than 10, the ghost path is selected randomly. But if the distance is lower and equal to the 10, ghost chases Pac-Man. For the pathfinding purpose, the A-star algorithm is used. We have also implemented the Jigsaw algorithm, but A-star is more optimistic in terms of the Jigsaw is kind of works heuristic. It finds the shortest path, but it does not have the ability to find a direction. So in A-star algorithm, in both literature and both the game was used. So we have preferred the A-star algorithm as well. As Ozan mentioned earlier, the biggest thing that we have provided to the game is now the ghosts can update their path without reaching predetermined final points. So in the previous part, in the base project, when the ghost senses the player, it goes to the location that it sensed at first, but until the ghost finishes its the finding the paths, the player can go to another location. So this means ghost chasing mechanism cannot update had not updated constantly. But in our implementation, ghost updates it at each period of the game. So ghost continuously tracks the player, and this becomes more challenging if the player has approached the ghost.
Yeah, and also in the base project, for example, if the ghost has determined a random position at a random point in the maze, uh, without reaching this destination, it wouldn't chase the player, even if the player has come close to it. So it only follows it only used to follow the current track it had, and without reaching its endpoint, it didn't update the next target. So that
Yeah,
is resolved
absolutely.
now.
We have seen that the pathfinding algorithm gives the part of the locations. The length of the location might be the 10. So without just finishing the 10 locations, without the visiting 10 locations, Ghost does not sense, did not have any sensing mechanism. if the player can be very close to the ghost, but the ghost cannot be chasing modus cannot be triggered. So we have also fixed that issue. Now if the player at any time is close to the ghost, ghost chases it without and also uh, breaks the old path and starts to the new path in a way to chase the player.
Yeah. So that was the ghost behavior AI, and let's finish it up with the analytics. We had implemented some analytics module into the project also. In this analytics module, we uh, mark the log file with some crucial parameters that will define the setup of the game. Uh, these parameters are power-up counts in the map, the portal gate counts, map size, ghost spawn frequency, and Manhattan distance limit. That is the sensing range, let's say. And these parameters define the setup of the game, and that can be valuable if, let's say, we were game developers in a company and we have released this game for the masses, and we have collected lots of data. We could say we could investigate the data and draw some insights about the effects of these parameters on gameplay. And Baran can continue with
Yeah,
the details of this analytics module.
yeah, and another, as Ozan said, it was the one reason, and another importance is these parameters allows us the set the difficulty. We can just analyze the players' behaviors, and we can see that the how difficult the player can play, and we can generate many different levels with different difficulty the sets of the difficulties. And another thing is, as you can see from the on the left side, the picture, we have seen that while the goes in the chase mode, we have seen the Manhattan distance scores. So we have also confirmed our algorithms. We have confirmed, verified the success of the algorithms from these analytics module. And as you can see from the right on the picture, we have all the logs. So we can see that we have implemented correctly, and we can see all the details about the game.
Yeah, and also these logs, of course, has some positions and the players' positions, then ghost positions, with their timestamps. The log records the game in a way with the tags and the labels of these parameters at the start. So this is our logging uh, module. And in conclusion, we had the opportunity to experiment with the algorithms and implement it with a tangible, real project like this game. And with our enhancements, the Pac-Man turned out to be a different project at the end with uh, a different gaming experience at each run with the dynamic maze generation, and the ghost behavior is now way better, and it's the random nature of it makes the game very interesting, and it was quite fun.
Yeah. Also, I want to thank Ali Ozan. It was really nice to work with him. It was really
It
great.
was a
It
pleasure.
has become a really great experience. It was a difficult but fun.
Yeah.
Also, I would like to thank Hussein and Ayojam. Thank you very much for this course. It was really valuable information. Thank you very much.
So thank you for everything. This was all from us, and wish the best for everybody else. So
Right.
thank you.
Thank you very much. Take care.
Thank you, Baron.